Think of the ovary like a basket of eggs. Females are born with their baskets full of eggs. Throughout life, the number of eggs in the basket steadily declines until no more eggs are left and menopause occurs. Although as we age, the eggs in the basket can become cracked, meaning that their quality is reduced. Importantly, both the number and the quality of eggs present defines a female's lifetime fertility, as no more eggs can be added to the basket after birth. However, there are many factors that can affect fertility. Exposure to cancer treatments like chemotherapy is one major factor. We've known for decades that chemotherapy treatment can dramatically reduce the number of eggs in the ovary, and many of the ones that are left are cracked. This leaves up to 80% of young girls and women with curable cancer at risk of infertility after their chemotherapy treatment. And critically, current fertility preservation options like egg and embryo freezing are limited and not even accessible to all patients. They focus on simply taking a few good eggs out of the basket and don't protect the ones that are left. Now, as a young woman who wishes to have children myself, I can understand why the majority of patients who experience infertility post-treatment report this as being almost as devastating as their cancer diagnosis. And that's why in my PhD, I'm developing a new fertility preservation strategy focused on protecting the eggs in the basket. Chemotherapy works by inducing damage to the DNA of cancer cells, causing them to die and the tumour to shrink. But unfortunately, this can also crack our eggs. We've previously shown that a specific protein called PUMA senses when an egg becomes damaged and signals that egg to die. And remarkably, when we genetically engineered mice without PUMA and treated them with high doses of chemotherapy, all the eggs remained in the basket and none of them were cracked. Now recently, a drug has become available that can block PUMA from functioning, called PUMA-I. And in my project, I am testing whether we can use PUMA-I to protect the eggs in the ovary when we deliver chemotherapy. Excitingly, we found that we can indeed rescue eggs from chemotherapy-induced damage using PUMA-I in mouse models and in human ovarian tissue. When we block PUMA, it acts like a band-aid on the cracks inflicted by the chemotherapy. The eggs actually have a chance to repair the damage, meaning that more of them can remain in the basket and their quality is restored. Chemotherapy is a life-saving treatment. We can't stop the chemotherapy from cracking our eggs because we need it to kill the cancer cells. But by blocking PUMA, we can help to uncrack the eggs and keep them in the basket where they belong. And we hope that this will revolutionise fertility preservation for young girls and women who survive their cancer. Thank you.